All right, so welcome to the wonderful world of PLCs. Before we get into any real technical information, I want to give you a little bit of overview about the trainer that you will be working with this semester. So, probably the most important part of this trainer is down here at the bottom right corner. That would be our PLC. Now, our PLC is only from this line over to this line. All right, we'll come back to the thing on the right for a minute. But that is our PLC. That is a Siemens S71214 AC/DC relay with the serial number or the model number being 1BG40. That's in the middle of it. I don't remember the whole thing, but that's the part that really matters. So that is our PLC. We'll come back to that one in a minute. Just to the left of our PLC, you can see we have power. So the red is going to be positive 24 volts, and the black is just going to be 0 volts. That is in the wonderful world of DC. The PLC itself has the actual power supply built into it with a little bit of short circuit protection. So if you do short circuit it, it will protect itself and turn off. However, the only way to get it turned back on is to unplug the PLC from AC power and then plug it back in with the whole system reboot. So don't want to do that. So far, I have been using white wires as positive and blue wires as negative. That doesn't mean that's how you're going to wire this. So just be aware that colors may change. What you will see is, especially if you were looking at this really closely, we have 5 red terminal blocks, and they are all grouped together by the little red bar here. You can actually see it easier on the black one. So right there's a little red bar, and that goes into those 5 terminal blocks and connects the 5 red together, and then there's a separate one that connects the 5 black together. So if you put anything to the red one, it's going to get 24 volts. It doesn't matter if it's top or bottom. If you put anything to the black one, it's going to be 0 volts. Traditionally, these terminal blocks just send power straight through. So the top screw connects to the bottom screw. So if you don't have that little bar there, it's not connecting anything together. So just something to be aware of, that bar is very important for outputting power and making this a uniform block, not just top terminal connected to the bottom terminal. To the left of all of this, we have our I/O for our trainers that we will be using. We are using Fisher Technique trainers most of the semester, or you're going to be simulating things on the HMI. But right here, there is a ribbon cable that will plug in, and that will connect to the actual trainer itself. So all the I/O for the trainer gets broken out onto all these little screw terminals. This allows you to keep your wiring from class to class, but allow you to disconnect the trainer for either for someone else to use it, or just for storing it after class and not having a mess of wires going everywhere. So that is what this little interface board does. There are a few important items on this interface board. It is these little jumper wires or jumper connectors. There's a blue one, a yellow one, and a green one. All right. The green one will internally connect pin 1 here right to pin 2. All right. That is important because on all the Fisher Technique trainers, pin 1 and 2 are both 24 volts DC. So by putting that little jumper there, you don't have to run 2 wires, one from here, one from there, over to the 24 volt rail, which is very convenient. Next, we have this jumper on the left-hand side, which on me is blue. And if we were to look at that up and close, you will see that there are 3 pins on that. One of them in the middle is should be labeled 1. Doesn't necessarily, it is, because my numbering did get screwed up on some of these. The top one is V+, and the bottom one is GND for ground. All right. And what we do is we put that jumper on it, and we're going to normally have that here. All right, for this first pin. And what that does is it connects the positive voltage right here to pin 1. So by having that jumper set to the top section and this jumper here, we are actually internally connecting 1, 2, and this V positive section all together. That, again, allows you to run 1 wire from here back over to there. It just makes your life a little bit easier. Do we necessarily have to use this? No, you could take positive voltage right from here and connect it over to positive, and you would be fine. This was a little bit more important before I had all these terminal blocks here, so you don't necessarily need to use that jumper. The other one over here, the yellow one, that is pin 26. So instead of 1, it is 2, 6. And we normally actually have that going the opposite way. So instead of being connected to the top, we are going to connect it to the bottom. because we need to connect pin 26, or I think 3 or 4. It's a whole bunch of ground options. But we need to connect one of those back to ground or 0 volts. So that's what that little yellow one on the right does. But again, not as important now that I have all these terminal power blocks here for distributing power. Up above that, we have our HMI. That is our human machine interface. This allows you to have a touchscreen. It also allows buttons down here on the bottom to be used for triggering actions on the PLC. This is done over Ethernet. We don't have to wire all this stuff up individually. Just one Ethernet cable back to the PLC is all that we need. I do have some simulations, so like I've simulated the little conveyor belt and things like that on here, so that way if you don't have a real trainer or you want to be working on this at home, you can just use the HMI instead. So that makes your life a little bit on the easier side. The top right up here, I have buttons. Now, the important thing to know is that the green and yellow are both going to be normally open. All right? And then our red one is going to be normally closed. This is important because most emergency stops, and maybe even stop buttons in industry, are going to be normally closed. That means you have to invert your logic that is in the PLC. So you will be wiring up that stop button at least once this semester and having to make sure that you've got the right symbol in the PLC software. If we actually look closely at the bottom of this box, you can see we've got a green, a red, and a blue wire coming down here. That's just connected up to the inputs on the PLC. And then this white wire, if we were to follow it, connects all the way back over here to our positive 24 volts. So our PLC inputs are syncing. They are expecting 24 volts for a high and 0 volts for a low signal. If it was sourcing, it would be the exact opposite way, but we are writing syncing. On the right of the PLC, I mentioned we'd come back to that. This is a little Ethernet, I believe it's a hub. I don't believe there's any smarts about this thing. It could be a switch, I'm not positive. Either way, it works roughly the same for our purposes. So if we actually would follow what we've got one Ethernet cable that plugs in down here on the bottom of the PLC, and then we've got one that goes all the way around and plugs back into your HMI. If you're missing either of those wires, make sure you add them. It is something that some people will take off, and sometimes we have to take them off because of my shelving unit being a little bit too tight right here where the Ethernet cable is. So just something to be aware of. So overall, that is our PLC trainer board. Now, if we zoom in on the PLC itself, all right, you can see that right here, we've got the model. So this is the S7-1200, as I mentioned to you all. And then down here, we've got the little submodel. This is the 1214C AC-DC relay. This also is showing it with the covers on. So there is a cover on right here, and there's a cover on right here, so you can't actually see the inputs and outputs that are going on. If we would scroll down to this picture where I've taken the cover off, you can now see all of the terminals. So we see everything that is going on here. So from here all the way over to there, those are our digital inputs. Notice that we start at 0, go to 7, and go back to 0, and then to 5. Down here at the bottom, we have our digital outputs, which are 0 through 4, and then 5 through 1 again. So we do have this 1L and this 2L here. Those are our commons. So whatever we feed into this screw terminal here, whatever voltage or ground, will get connected to all of these via relays when you turn those outputs on. We will be using 24 volts DC, so you'll actually take a wire from one of these red terminal blocks over here on the left, and you'll come screw it into 1L, and then you'll take another wire, if necessary, and screw it into 2L. The benefit of having two separate common points is we could run 24 volts on this one, and we could do 120 volts on this one AC. Because these are relays, it can be both AC or DC, so it doesn't matter which way we go with that, which is really convenient for our purposes. Over here, on the left a little bit, you will notice that there are some more screw terminals. Those are our analog outputs, and then up here at the top, we have our analog inputs. I did forget to mention one very important thing. On the inputs, you see we have 1M. Down here, we had 1L, 2L. That's saying traditionally that that's going to be our positive. Up here we have an M, which is telling us it's our negative, or our ground, or our 0 volt rail. Right to the left of this, you'll notice that we've got 24 volts DC, so you can see L plus and M. Why do we use L plus and M? I do not know. This is a Siemens PLC. That's the verbiage that they go with, but our best guess is it's something in German or some other European language that it makes more sense that way. But M is our common for our 0 volt negative rail, again, whatever you want to call it. And internally on this board, you can just barely see it right here, there is a little jumper wire. So it internally comes out onto that PCB and then comes right back on. If you do not have this board here with all the little switches on it, that little jumper's not there, so you need to take this from the 1M, and we need to connect that to our black screw terminal distribution block on the left-hand side there. Otherwise, none of your inputs will work correctly. So that is very important. Earlier in this video, you heard me mention the 1BG40. Right here beneath the output flat is where you would find that. So this is of the 1214C AC/DC relay section. This is the 214-1BG40s-OXBO. All right. But again, the 1BG40, this is what changes on the model inside the 1214C AC/DC relay. So that's all you really need to remember. It is important to make sure you've selected the right model, otherwise it will wreak a little bit of havoc when you're trying to download things. So please make sure you select the right one, which I will show you in our next video. But that is all I've got for our quick review of the trainer boards. Hope you found that helpful. If you have any questions, don't hesitate to let me know.